Perfect. All right, everybody. Thank you so much for joining. My name is Kate Foster. I'm the account manager here at IHEA, and we appreciate you registering for today's workshop, Discrimination Against Doctors, a Field Experiment. Today's webinar will run for approximately 60 minutes and will be recorded and uploaded on our website afterwards. Before we begin the webinar, I just wanted to run through a couple quick housekeeping items. If you experience any technical issues during today's webinar, please write them in the chat box at the bottom of your screen, and I'll be happy to assist. Everyone on the line has been muted except for the speakers in an effort to eliminate background noise. But if you'd like to speak aloud, please feel free to use the raise your hand function and unmute. We will be holding all questions until the end, where we'll open up for a facilitated Q&A portion of the session. And I will now pass it over to our convener, Matthew. Matthew, over to you.
Thanks, Kate. It's a pleasure to introduce Alex. Alex is a PhD candidate at Stanford University. He's going to finish up in May next year, and we're really excited to hear his talk on discrimination against doctors, a field experiment. Alex, I'm going to throw it straight over to you, and then we can come back for some questions and discussion afterwards.
All right, so thank you so much it's a great pleasure to talk to everyone here. I'm, as Matt mentioned, I am on the job market. So this is my job market paper, in fact. So I'm going to talk to you today about the field experiment, right? So to tee it up a little bit, right? What I'm going to do is, I hope by the end of this experiment, this talk, we could sort of take away a couple of things. One thing is that I would have proposed sort of experimental design for, the three choice experiment that I think could sort of point to a direction that we could bring economists and marketing folks and people in the rest of health economics that uses some sort of conjoint design type studies to actually come together to try to agree that we could do something with a similar methodology and find results that we could all find credible. Second is that it touches on a very important phenomenon that I think that hopefully more people will look into as this progresses, which is the phenomenon of discrimination against doctors. So with that, let me actually motivate it a little bit. So in the middle, at the heart of healthcare production is the interaction between doctors and patients, right? So if you have discrimination that exists in the middle of this interaction, right, you can imagine there's major welfare implications. Now, one direction of this where doctors' discrimination against patients is something that we know quite a bit about, where a lot of studies have looked into how it might impact patient satisfaction, a lower ability to diagnose correctly, and it could even lead to bad health outcomes. But the other direction of patients' discrimination against doctors is something that we know much, much less about, right? There's some anecdotal interview type evidence. There's some evidence about how patients might trust doctors of different races more or less. Think about Marcella Alson's work. But this whole concept of discrimination against doctors when they're picking which doctor to go with is something that we know very little about. So in this paper, I asked the following two questions. One, do patients discriminate against doctors on the basis of race? Two, what's the nature of such discrimination? Right? Is it taste-based discrimination? Think about the Gary Becker type, where people have a preference to not associate with a doctor. Let's say they just don't want a black doctor, regardless of quality. The second mechanism is potentially statistical discrimination, or the case where patients are using race as a proxy for quality for the doctors. In the case of Arrow and Phelps, they also assume that at equilibrium, right, people have accurate beliefs about doctors. The other mechanism could be something else, because behavioral economics had advanced quite a bit in how we think about discrimination. So there are many new theories about discrimination that we have put forward, and I'm going to talk a little bit more about them. The spoiler alert here is that the traditional mechanisms of taste-based and statistical discrimination would not be sufficient to try to understand what we see in the data here. Okay, to motivate my empirical exercise, let me try to outline what I think, at least, right, what an ideal experiment might look like. I think an ideal experiment, to answer those two questions that I have earlier, is to look at actual patients who are actually shopping for doctors. Okay. In particular, we might also want to have actual patients shopping for doctors in a setting where I could actually exogenously vary doctor attributes. Because if we want to sort of figure out, how different doctor attributes might cause a higher or lower choice probability, we want to have exogenous variation in doctor attributes. We also want to observe the full choice set. What I mean by that is when I see patients picking Dr. A, I want to know which other doctors they have considered, okay? These two things are typically pretty hard to accomplish, right, with observational data. If you think about, health economists like us, right, our bread and butter is using, administrative data like claims data and so forth, right? These observational data, you might worry about endogeneity, right? Doctors' race might be correlated with some other things. And furthermore, in many places, for example, my friend who comes from Alaska, where he lives, there's not a single Black doctor that he have encountered, okay? So you might not have enough variation in race for us to be able to do this empirical exercise. Now, constantly in an ideal environment like this, we might also want the ability to vary whether a quality signal is available or not. Right? Why do I want that? Because that's the traditional test for statistical discrimination. If you think about field experiments that study discrimination in general, right, very often what people do is to vary whether the people who are shopping or making decisions or hiring, whether they see additional quality signal or not. And that's a way to test for statistical discrimination traditionally. And now also at the end of this, hopefully I will convince you that this test might not be enough and we need new technology, so to speak. So this paper, in a sense, right, it's a little bit of a call to arms for the empiricists to try to say, look, let's catch up with the theories that we have about discrimination and develop the right empirical methodology that allows us to say more about what we are observing. Okay. It talks to a bunch of different literature. The first branch is that it talks to the literature on customer discrimination. The thing that's new about this is that it's really one of the very few papers that I know of that actually look at customer discrimination in a very significant labor market. The United States is like 13% of the workforce are in the healthcare sector. So that's a big market that we want to look at. The second is that it's also contributed to this literature that talks about how quality signals might impact minority job market candidates' outcomes. Right? Think about, there's this literature on ban the box where there's a policy to ban the employers from asking, there's a box that indicate whether the prospective employee have had a criminal record in the past. So a quality signal for that employee. When they ban that box, meaning that they remove a quality signal from that market, it turns out that it harmed the average minority job market candidate. So it talks to that literature too. Now, it also talks to it. This is something interesting that I think is a more general purpose technology type angle, is that it expands on the incentivized methodology to study preferences. What I mean by that is, instead of just making people do hypothetical choices, there's increasingly this move towards trying to incentivize these preference elicitation exercises as well. So this talks to this, and I think that I make an empirical innovation that goes beyond what the literature has been doing today. Finally, it also, talks to providing evidence for us to think about these behavioral mechanisms of discrimination. The thing to remember here is that I think we've advanced a lot in terms of how we, think about the theories about discrimination since 1950s and 1970s. This provides the evidence, and I try to engage this literature in the sense that, we want to think about, well, it's the tests on empirical exercises catching up with the theory necessarily. So I'm going to do an outline of what I'm going to talk about today. But before I do, I want to just quickly make a point to everyone that, I'm an American academic, so you should interrupt me anytime you like. Don't even need to raise hand, just like jump in and talk, and we could have a discussion whenever you have a question. Okay. All right. So today I'm going to quickly tell you about the empirical, like the experimental setting and the design of the experiment. And I'm going to go through a bunch of results and data, and let's talk a little bit about the possible mechanisms after that, and then we'll conclude. Okay. The first part of it is experimental setting. So let me dive right into this. I mentioned earlier that in an ideal environment, I want to study patients who are actually shopping for procedure. But what patients would make a very good subject pool for this, right? For us to be able to study discrimination, basically kind of compare how people trade off doctors of different races, with price, with travel distance, and all these things, right? So ideally, I want patients that are shopping for a common procedure. Ideally, it's also a procedure that have a clear price, because we want to study things like willingness to pay. It's really hard to think about things like cancer care, where it could be a bunch of different things for different people. It could be different procedures, different lengths of treatment, and so forth. So it's really hard to pinpoint what we mean by a price of a cancer care. But if we have something that has a clear bundle, a clear episode of care, then that's a nice setting to do this. Finally, we also want a procedure that has high volume in the field setting that I'm able to access. Okay, so a candidate for this is colonoscopies. Colonoscopy, it's a recommended screening procedure for people over 45 years old, right, by the U.S. Preventative Task Force. And it could be priced as a bundle very clearly, right? You can say what the price of a colonoscopy is. And the other super nice thing is that it's the most shopped for procedure in the field setting that I use. So what's the field setting? The field setting is this online platform for healthcare consumers, right? If you have used sort of Priceline or Hotwire to shop for a hotel, you might be familiar with how this works. Roughly speaking, on these type of platforms, like in the Hotwire case, for example, is that you will see a bunch of hotel options. You see the price quotes from the hotels, but you see limited information. You see approximately where the hotel is, and you see a bunch of stuff about the hotel, maybe the customer rating of the hotel, but you don't know exactly which hotel it is until you commit to book. Here, it's a similar setup. Okay, patients see a bunch of stuff about the doctor, but not exactly who it is. Once they commit to book, then they find out which doctor it is. Now, most people, like, in the United States or abroad, you don't use a website like this because, in the UK, for example, you have in the rest, a lot of the civilized world, you have universal health coverage. In the United States, there are 30 million Americans who are not insured, right? To give a sense of how big that is, that's like 3 times the population of Sweden. So like 3 Swedens in the United States who are not insured. So a lot of people are cash paying, right? They are shopping online, and this platform is very popular with this crowd. Okay, now on this platform, what do I do, right? Remember that I mentioned earlier, in this platform, the typical shopping experience is such that patients would get to see the price, information about location, the gender, a non-identifying avatar of the doctors before they make a choice. So in this experiment, I do the same thing. I have patients evaluate hypothetical doctor options, right? Doctor options that looks like this. Each menu would have 5 doctor options and a none of the above option, and they have to pick one for each menu. Okay? In particular, what do they see? Right? They see the race of the doctor, which is indicated by a blurred picture, like the one that you see here. The race shows through, but not the quote-unquote attractiveness of the doctor. This is a similar approach that was used by Christina Fong and Ursula Ludmer in their work. Try to use a blurred picture to indicate race without giving away attractiveness. I make sure that you don't necessarily get a lot of information about attractiveness of the doctor by also doing an additional prolific survey to have people rate the doctors in terms of attractiveness and perceived age. And I also take the underlying picture of the doctors and I run them through a facial symmetry detection algorithm. And I find that there's no difference in, either the prolific results on attractiveness, perceived age, and facial symmetry across race. Okay, so that's how race is indicated. The second element that we see here is gender. Gender is stated explicitly and indicated by the picture. The reason why gender is stated explicitly, right, different from race, is because when you shop for a doctor, typically you could see the gender of the doctor. And the typical shopping experience on this website, also I mentioned earlier, right, you can see the gender of the doctor. So part of this is to make it resemble what people would see typically when they shop for a doctor. So it's like a natural shopping environment for them, right? So that's what they have. The next bundle, the next doctor attribute is travel distance to the doctor, right? You could take on 5 different levels, 0 to 10 miles, 10 to 50 miles, 50 to 100 miles, 100 to 250 miles, and so forth. To give a sense of if you don't use miles, 100 miles is about 160 kilometers. And finally, you have price. The prices that I present in these hypothetical doctor options are all drawn from actual doctor prices. Okay, they're all drawn from what you would, if you see a price that is in one of these hypothetical doctor options, you will see an actual price that is at that level. Okay, in other words, if you see a doctor in this profile, like you could imagine that this is a real doctor that you could see, that you could potentially book with. The order of these attributes are randomized across subjects, meaning that some patients would see the race first, some people might see travel distance first, but the price is always presented as the last attribute. Okay, so the first source of experimental variation, right, embedded in what I just talked about, is that I have people look at these hypothetical doctor menus. The thing that I vary first is the attribute levels and the combination of these attributes. Okay, so that's the first source of experimental variation. Now, the second source of experimental variation is I vary the availability of information on doctor quality. They will see a quality signal in the treatment arm that, they see 1 to 5 stars for the doctor's quality. There are 2 treatment arms. One of them, people will see doctor profiles like the one you saw earlier, no quality signals. In the other arm, they will see doctor profiles where there's also a doctor quality signal, like the one on top. You might ask, what is a doctor quality signal, right? These doctor quality signals is a comprehensive quality score that's made up of 3 components. One are these average ratings on health grades, vital, and so forth, which are popular websites where doctors' ratings are published. And also 2 quote-unquote more objective measures like years of experience and the ranking of the medical school and residency and fellowship and so forth. And when the subjects are randomized into the arm where they see the quality signals, they also see an information screen where they actually are shown that the comprehensive quality score is correlated with all three of these. In other words, when the comprehensive quality score goes higher and higher, not just the average ratings are higher, but also doctors have more experience, they go to a higher ranked medical schools and so forth. Okay. Now let me show you quickly what the distribution look like. They basically they're 1 to 5 stars, and these are, doctors of different races, just a histogram. The one thing to take away is not everyone, they recalibrated the ratings so that not everyone is like Uber, where everyone's like between 4.5 to 5. Okay, so it's an informative signal. Now to zoom in on this is a CDF for black versus white doctor. Black doctors are the one with red bars. White doctors are the one with gray bars. The one thing that I want you to take away here is that there is an average quality difference among the real actual doctors, not the hypothetical doctors. For the hypothetical doctors, it will be evenly distributed across the 5 stars, right? Because I exogenously vary the levels, if you remember, right? But among the actual doctors, there is a small quality difference on the average level for the score, but it's less than 1 star. So I want you to remember this figure of 1 star difference between black and white doctors, because when we come back to interpretation, I'm going to draw on this fact again. Okay. So, how do I generate the data? I have people, like I mentioned, evaluate 5 options per menu, and I have them evaluate 14 of these menus of hypothetical doctor options to generate the data. And I use a fractional factorial menu design. And in particular, I try to optimize balance, overlap, and other characteristics that helps me basically generate as much variation, as much information as I could from these choices across the different menus within the same subject and across subjects. Okay. The one thing, of course, is that the attribute levels are independent, and I try to have them range as much as possible across the different levels so we could get at everything. Okay. So one thing that we might worry about so far, because we were making hypothetical decisions, and very often, if you look at the marketing literature, in a certain sense, in a lot of what we do in health economics and health policy, we also do sometimes ask people to make hypothetical decisions. But in the experimental economics literature and in a lot of the other parts of economics, people might worry about hypothetical bias. What I mean by that is when people are making hypothetical decisions, you might worry that people may not be expressing their true preferences. So we want sometimes we want to incentivize choices, even when we're making hypothetical decisions. The way that I do this is that I tell patients basically how they choose among those 14 menus of hypothetical doctors will determine which 10 actual doctors they're going to be matched with and they could book with. Okay? In particular, based on how they choose on those 14 hypothetical doctor menus, they get mapped to 10 actual doctor options, 8 of which have the highest match score based on how they chose in the 14 menus. And then I draw 2 more random ones from the remaining set of doctors, and I scramble the order of how the doctors are presented to the patients, and they're presented to the patients. That's the thing that this is similar to this work, incentivized resume rating, if you're familiar with that work, where people present hypothetical resumes in order to map people to real resumes. That this paper in 2019 in the American Economic Review by Kessler and Sullivan did exactly that. Now, the thing that this previous literature does not do is that I actually then go ahead a step further and I take the actual bookings. In other words, after the patients are presented with the 10 actual doctor options, I look at which doctor they booked with, okay? And then I use that data, that choice data, to validate the preferences that I estimated from those 14 menus that I generated, okay? This is a step that I call validation, which makes this an incentivized and validated design compared to the ones previously that I just incentivized and not validated.
Alex, could I ask a quick question, please? Sorry, put my camera on. Or try to put my camera on. Sorry, my computer's being a bit slow. So just going back to the last slide. But surely, the actual booking would be some way related to the series of choices they have before them, right? If I'm understanding this correctly. So do you have some sort of endogeneity problem in that your actual booking choices are dependent on the 14 hypotheticals that you made before that, and therefore, is it a reasonable comparison to look at that as a validation tool?
Yeah, so the actual bookings, so the actual options are generated by how they pick in the 14 choices. There are two random ones. Those two obviously has nothing to do with how they picked in the 14 menus, but the 8 that they pick out for them, they come from the 14 hypothetical menus. But the nice thing that I'll come to this in 2 slides, but I'll give you a preview, is that how they pick among those 10, right? Yes, even if the menus are generated so that 8 of them are something that they would love, right? But how do they pick among those 8? Or more broadly, how do they pick among those 10? That's something that we could try to predict using the model that we have from them, from the 14 menus. And if that sort of matches how they pick among those 10, right, that gives us a lot more confidence about the preferences that we estimated. Now, the thing about those 14 choices, then you might ask, like, why don't we just estimate everything from the actual bookings? The thing is, with the actual bookings, we come back to the earlier point that we mentioned, where you might not have enough variation in doctors' race, you might worry about endogeneity. The 14 menus, I know I don't have that problem because I generated them randomly. So what we want to do is like really study the preferences from those 14 menus, but check that they indeed are they're not deviating from what people actually do when they have a chance to do something. That's what I'm doing here.
That's cool. Okay, yeah, I'm looking forward to see the results. Thank you.
Cool. Thank you for the question. All right, so just quickly sort of make sure that we're recapping, sort of we all know what I did. Cash paying patients, I recruited them through the email for the platform. So everyone's used the platform, so they're familiar with this shopping environment. So for them, this is a familiar shopping environment, which is a good thing with conjoint designs, coincidentally, because a lot of people do this hypothetical decisions, but they create some really weird interface and experience might be different. That's a limitation. McFadden really does not like that. And so like Danny McFadden really doesn't like that. So the one thing that McFadden wants people to do when they do that is to say, look, a familiar choice environment would be nice. And this experiment, that's a very nice attribute, and that people are used to making doctor choices this way. It's pre-registered. It ran from the end of 2020 to March 2021. I'm just going to skip that and show you results. The first thing I'm going to show is just, we have achieved balance across the 2 groups, but I want to caveat that this is not a representative samples of the US population. Right? In particular, right, for example, people are not all uninsured across the US, evenly. And second is that, the age group, for example, most of my subjects are between 45 to 64, because if you're under 45, you don't need a colonoscopy. If you're 65 or older, America joined the rest of the civilized world that we insure everyone. So there's Medicare that kicks in. So they're not cash paying uninsured people anymore. Okay, so I'm coming back to John, your point about how do I think about validation here, right? So let me orient everyone to this graph here. What you're going to see next to 1 would be among the actual bookings, what's the proportion of the actual bookings that booked with the predicted first choice? So out of everybody's individual menu of 10, like the predicted first choice. The next to 2 with predicted second choice, predicted third choice, predicted fourth choice, and so forth. And then the 2 random doctor options will be in the bottom. So if we think that, we want to make the argument that, look, this actual booking data validates the estimated preferences, what we hope to see is a bunch of things. At least we should see that, most people hopefully pick their predicted first choice when they actually book a doctor. Second is when they actually book a doctor, right? The options with a lower choice, probably predicted choice rank, hopefully they're less and less chosen as the choice rank drops. And finally, right, hopefully no one picked the random options, because the 8 are selected among hundreds of doctors that are supposedly the best fit for them. Okay, so let's see the actual data. So sure enough, most people actually do pick the predicted first choice, and the proportion of people who book with the lower choice rank one drops as the choice rank become less attractive, and then nobody picked the 2 random options. There's a top 3 accuracy score of this of 82% of time. I never understood how to think about top 3 accuracy score or top 5 or accuracy scores in general. But to give you a benchmark, I learned that, for example, on Netflix, they achieve what they want to do with their recommended movies out of the 2,000 that they have at any given time, is that they want the 200 or so that they present to people, or 200 and 300 movies that they recommend to people, to have an accuracy score of around 80%. So that's the context you can have here. Now, because we're trying to study preferences over race, right? You want to check some things here, because you might worry that there's some residual effects of race that are not getting picked up by the predicted choice, the preferences that you got from the hypothetical menus. So one thing I do here is that I try to see, conditional on the choice ranks, do race offer additional predictive power? And it doesn't. So that's good news. On the other direction, right, when you don't allow us to make the predicted choice rank using race, in other words, I estimate the predicted choice probabilities from the hypothetical menus, but I don't let you use the race variables as arguments in your discrete choice models. Okay, then you get the red bars instead of the gray bars. You can see that it's less predictive, right? So the predicted first choice that fewer people will pick it, predicted second choice fewer people will pick it, and so forth. Okay, so the race actually is sort of somewhat incorporated into some of these what we get from the hypothetical doctor menus. Now, the other thing that you might want to do is to actually look at make a discrete choice, estimate a discrete choice model from the actual booking data itself, right? And we could just compare that with what you get from the 14 hypothetical doctor menus. The hypothetical doctor menu data is a lot richer. You have a lot more data, a lot more information. So we want to use that, but we could compare them to see whether they are different. So in fact, they're not, right? The key results that you will see in the subsequent sections from using the hypothetical choice data is statistically indistinguishable from the actual booking data if you estimate preferences from them. Now, it's much less precise because now instead of like each person making 14 choices on 14 menus, each person is just making one choice on one menu. So you have a lot less data. But, both magnitude-wise and sort of statistical indistinguishability, you can't really tell. They're similar across the two. Finally, you might worry that maybe bookings don't convert into actual colonoscopy. So the platform did provider interviews. But we basically have evidence that all these bookings converted into actual clinical encounters. Okay, so what I do, I will use this 14 hypothetical doctor menu choice data to estimate preferences. How do I do that? I will just estimate a bunch of behavioral parameters, right, that help me rationalize the sequence of choices that each individual makes, right, the 14 choices that everyone makes. In particular, I assume that the consumers have a linear indirect utility function from choosing Dr. D that is made of 3 components. 1 is the utility that customer I gets from Dr. D. 2 is the utility for money. And 3 is this error term that follows a type 1 extreme value distribution. And what I'm doing here is I'm just estimating generalized multinomial logit with random coefficients. The one assumption I make here that's important is that I make an assumption that the marginal utility is a linear function of doctor attributes, right? Attributes like race, gender, travel distance, and so forth that are captured by these lambda terms. I mean, you could also imagine that I use interaction terms like quality interacted with race or something like this, but they're captured by these lambda terms. When I present my main results, right, I need to compare between treatment control arms, and I want to make sure that they're interpretable for people, right? You want to know, like, what does it mean, like, in terms of, like, what's the discrimination against doctors standing for? So I'm going to present things in terms of willingness to pay or money metric utility to get more comparable estimates, and so they're also estimates that are easy to interpret. And I'll present it by willingness to pay, and all you do is that you basically take those lambdas from earlier and you divide it by price coefficient. Okay, that's how you get this willingness to pay. And so let me show you some results. I'm trying to do this in the next maybe 15 minutes. So I'm going to skip some stuff, but I want to show you the main results and talk a little bit about interpretation, because I think that's the interesting part. So I won't show you as much, heterogeneities, but I'll show you this main result. What you're going to see here is I'm going to present you the willingness to pay for Black and Asian doctors relative to white doctors. Okay? In particular, you see 0 here. If the bars go down and they're negative, that means that there is a willingness to pay penalty on the Black and the Asian doctors. If it is positive, but if it goes above 0, that means that you get a willingness to pay premium for Black and Asian doctors. So they want Black and Asian doctors instead of white doctors. Okay, so that's how to read this graph. So let's see what happens when there is no quality signal. When there are no quality signals, Black doctors face a willingness to pay penalty that is about 12.7% of the average price, $270. That is, another way to think about this is that it's similar to people willing to travel 160 kilometers or 100 miles or more just to get a white doctor instead of a Black doctor. Okay? For Asian doctors, you have a significantly lower amount of willingness to pay penalty, but it's still very significant at 8.7% of the average price. Okay. So what happens when you have a quality signal? Remember I mentioned earlier that the reason why we even couldn't compare this is try to test for whether it's taste-based versus statistical discrimination. That's how the traditional approach would look like. In other words, what would appear instead of these question marks? Right? If it's purely case-based discrimination in the 1957 Gary Becker kind of sense, but you will see these two bars being replicated exactly to the right, right? They will look the same. But if it is traditional statistical discrimination or some of these other behavioral economics models of the discrimination, you might see these bars shift. So let's see what we actually see. So we see a 90% drop in the willingness to pay penalty. Now, there is a significant residual, as you can see there, right? But the drop is massive. Right? 90% of this willingness to pay penalty on Black and Asian doctors pretty much goes away when you show people a quality signal about these doctors. Okay, this is the main result, and it's very important to think about because we need to. The next thing I'm going to do, I'm going to skip over a bunch of stuff, and I'm going to try to interpret these results. Okay,
Alex, just before you get on that, sorry, I have another question if that's not too annoying for you. But just before we get there, does that just trying to understand this? Is this willingness to pay from a model on all of the sample, and does all of the sample have both? I don't know, like a mix of races in there.
Mm-hmm.
So, I'm curious as to the willingness to pay for doctors as a function of individuals' own characteristics.
Absolutely. Right. So the question that you want to naturally ask is, well, does it apply both equally to white or Black patients? Right. So let's see just for white patients what they look like. Okay. So white patients, I'm just showing Black doctors. I'm just simple. White patients kind of look like the overall population because most of the sample is white anyway, right? As I mentioned earlier, discrimination, and then it drops a lot, but the residual is significant. That's how it looks like for white patients. For Black patients, when there's no quality signals, there's still a significant penalty on Black doctors. A lot less, but they're still significant. But be mindful that this is very imprecisely estimated because I only have very few Black patients. But when there is a quality signal, the willingness to pay penalty on Black patients on Black doctors goes away entirely. Okay, if anything, the point estimate is sort of positive. Okay, so I think that answers the question that you meant to ask earlier. Is that does it differ by racial concordance essentially? So you can imagine that there, it's sort of this is what we see. The direction of the drop is similar. Okay, I'm going to now speed past a bunch of slides because I do want to get to the mechanisms part of this. I'm going to speed past a bunch of this. So I want to mention just this, in that, you might, the results that we shown earlier are robust to, excluding menus that quote unquote do not look representative. Because the nice thing about the design, right, these hypothetical doctor menus is that I exogenously vary the levels of different things so that I get as much information out of these choices as possible. But the downside is you might generate menus that might not look like how the composition of American doctors might be, because American doctors, like 50 to 60% white doctors, 20, 40% Asian doctors, maybe less than 10% Black doctors. But there might be menus that you saw there that could be, let's say 4 Black doctors and 1 Asian doctor, and they're all men, right? That might not be representative. So we could exclude the menus that do not at least have, let's say, 3 white doctors, 60% white doctors, and they have to at least have, 40% doctors of either gender, right? If we only keep those menus, you will see that the results are the same. The other thing you might want to check is, patients with or without previous colonoscopy experience, right? The results are the same. Did patient book eventually? Most patients booked, but not all of them, right? Around 10% of them did not book. So if we just take people who booked versus did not book, the results are again the same. So there's a bunch of robustness things that we try, and that's nice to know. So I'm going to jump over all this. These are really cool results too, by the way, willingness to travel for care, but I'm going to skip over them. I'm going to talk about possible mechanisms. In particular, I mentioned earlier that there are these models of discrimination, like the classics, 1950, taste-based discrimination and statistical discrimination. I've mentioned them. I'm not going to talk about it. But a lot of the field work that thinks about testing discrimination has been focused on distinguishing these first 2 types of discrimination. But there are new work that start to challenge this dichotomy, right? For instance, the Iceland Bowen, Alex Imash, and other co-authors, they have this work on inaccurate statistical discrimination. So people are doing statistical discrimination, but they have inaccurate priors. So the door is starting to break open, but I think, as hopefully by the end of this section, I could convince you that we need to do a lot more in this space. So I hope that I remind everyone this is the main result. Single interpretation, in particular, let's just focus on the Black doctors. In particular, let's focus on this drop of 11.5 percentage point and the residual of 1.2%. How do we interpret these results? Okay, so some people note the question marks, but some people might interpret that, oh, even with quality signal, there's a residual. So that could be taste-based discrimination against Black doctors. Okay, we have to be careful to interpret this, because what those people would have made as assumptions when they make that claim is that the assumption is that, well, the signal is strong enough, because if the quality signal is not strong enough, maybe there's a residual in that for that reason. Second, it could be some more complex behavioral models that could be driving this. So that's why I have 2 questions marked behind it. But some people with stronger assumptions might claim that that's residual taste-based discrimination. Okay? But the thing that we think about here, I mentioned earlier, is that this test, the traditional test for statistical discrimination, is this drop, right? The provision of quality information and the associated drop is the traditional test for statistical discrimination. Now, but if you take the Arrow-Phelps statistical discrimination seriously, it doesn't just tell you that there's a drop, but it also tells you quantitatively how big of a drop it should be, right? So in order to interpret this and actually take this theory a little bit further to try to bang it against the data that we have, let me share a little bit more information so that we can think about this. Now, one thing I want to show you first is the willingness to pay for doctors with higher quality scores. Okay, what I'm going to show you here is relative to 1-star doctors. So if it's positive, people want more doctor with more stars. If it's negative, people want doctor with fewer stars. So for 2, 3, 4, 5 stars, they all, patients generally prefer doctors with more stars. But the interesting figure here to note is that the biggest difference between the doctor quality tiers, 5-star doctors versus 1-star doctors, is just really 3.3%. Okay? This is a lot less than the drop that I showed earlier, the 11.5%. If I put it here next to them side by side, right? What I just show you, the 1 5-star doctor gap is just this double-sided arrow here, which is a lot less. Now, you might now think, well, maybe the patient's actually thinking that the quality signal is too coarse to pick up the differences, right? In other words, maybe when I think about 1-star Black doctor, I'm thinking that the Black doctor is actually like negative 10 stars, but it's just not picked up by the quality score itself. So we can look at quality score levels interacted by the doctor's race to see whether that could help us sort of stretch this arrow, double-sided arrow, a little bit. Now, what you see here is that the Black-white gap by quality tier, the first bar that you see from the left here, right, is if the doctors are 1-star, Black doctors incur an additional willingness to pay penalty. But on the other direction, if you see that a doctor is 4 to 5 stars, Black doctors actually get an additional bump, right? You can think of it as maybe people think that maybe the quality signals are biased against doctors of minority races. So if a Black doctor somehow still got 4 to 5 stars, they got to be amazing, right? That might explain this, but even with this, the magnitude of all of this is 5.2%. Now, what I'm going to do now is something that's not really reasonable, but let's consider it anyway. In that, if I consider the willingness to pay difference between a 1-star Black doctor, like 1 star is the lowest quality tier, and the Black doctors, if they're 1-star, they get an additional penalty, right? Compared to 5-star Black doctor, which is the highest possibility 5 stars highest quality tier, and then Black doctors get an additional bump. So even if I consider that biggest possible difference among between doctors, you would still not be able to cover the entire drop there, right? If you combine these two, still not big enough to cover the whole drop. So you might have to think about, this really, really makes it very difficult for traditional accurate statistical discrimination to really explain this gap. Now, you could try to stretch this by thinking that maybe it's some sort of statistical mechanism, but like Boren et al., we talk about inaccurate beliefs or biased beliefs. Or it could be inaccurate stereotypes. It could be a bunch of different things that could have stretched it beyond what you see with accurate beliefs. Now, the other thing but then are these the only ones, right? I mean, I don't think that this could tell you exactly which mechanism it is. And furthermore, we might not even be able to just rule out we might not even be able to just easily say that, oh, it's just these kind of statistical discrimination mechanisms, but we allow people to have crazy beliefs. maybe that's not the only things that we need to consider, because let me show you one other result. This is a result by gender. Again, this is like 0, which this is relative to male doctors. This is 0. If it's positive, you want female doctors. If it's negative, you want male doctors. And this is split between female patients and male patients. Without a quality signal, both patients prefer doctors of the same gender, right? Male patients prefer male doctors, female patients prefer female doctors. With the quality signal, both patients that are male or female, they express less gender preference. Now, the thing that's tricky here is that the direction of the updating, right, goes in the exact opposite directions. But this poses a very strong challenge, because if you believe that everyone in this model, you cannot have people all have accurate priors and actually exhibit this kind of updating that goes the opposite direction. Okay, that's just like really hard to do. Now, you could justify this by having very more complex, inaccurate beliefs that differ by gender, and so the biased beliefs are different, for men and for women and so forth, right? But it's more of a stretch. But this suggests that one other thing that we could consider is this concept of more wiggle room. So I come back to this kind of like prejudice, taste-based type argument. Maybe what it is that, with the lack of information about quality, customers are now given more wiggle room. So they can express antisocial behavior, right? Like discrimination. So if they care about social image, like they take advantage of more wiggle room to express discrimination. So maybe that's what we're seeing. So again, we come back to these kind of like more complex models that allow us to think about these non-statistical discrimination mechanisms that we again cannot rule out in this model. Now, so what's the takeaway? Right, the takeaway is that various behavioral mechanisms could lead to discrimination that are observed, right? But we have to make very strong additional assumptions, like people have really insane beliefs on the baseline, or people have like those kind of things, to make a strong conclusion about not just the beliefs about the distribution of doctor quality, but also the beliefs about the signal variance and various things, right? But one thing that I could conclude here is that we need to consider beyond the traditional taste-based and accurate statistical discrimination mechanisms, like biased belief, deniable prejudice that I mentioned earlier. So the critique that I make here, which is one of the very important contributions, is that I want to say that the traditional comparative statics test that uses information provision to test for statistical discrimination is not conclusive, right? There are already additional information that we know that we need to gather. For instance, Bowen et al., they said that we should solicit priors. But what I'm saying is, you might need to do more, because once you think about the family of different kind of behavioral models that could explain discrimination, you might need to devise better tests. And I'm working on follow-up work to think about this. And this is sort of a call to arms to say that we should remain humble about what we know. And we might need to think about going to revisit some of these older work that we have used this comparative statics test to start to think about, what else we need to develop, so that the empirical world, the experimental work surrounding discrimination, could catch up with the theory and the models that we have from behavioral economics that thinks about discrimination. Okay, just to conclude, conducted a field experiment with actual colonoscopy shoppers. Patients evaluate hypothetical doctors get matched with actual doctors, which incentivizes them, and I used the actual booking to validate the estimated preferences. There are two groups that see the quality signal, groups that did not. And the finding is that we find that people discriminate against Black and Asian doctors, and that discrimination shrinks substantially when you provide quality information. And I think the main conclusion here is that we rule out that we could rely on merely the two traditional mechanisms of traditional taste-based and traditional statistical discrimination. We have to consider behavioral mechanisms. But once we start considering behavioral mechanisms, the floodgates open. That means that both my paper and a lot of the previous papers that have tested for mechanisms are not conclusive. So we have to develop better techniques and more methods to think about all of this other models that could be valid. So I'll make a methodological contribution here as well. And finally, the nice sort of story is that one of the results is that a positive policy implication of this is that quality signals can help reduce discrimination. So the platform actually has introduced this into the IT production pipeline, so that they are going to introduce quality signals consistently across the doctor options as the next stage of their interface. So I will pause. I apologize for this. I could probably stay for 5 more minutes, and then I have to go to my next thing. So to give and I'm doing an interview actually. So I want to open up and see if there are any. I'm going to stop sharing so I can see all of you. If you have any questions, comments, or discussions in the next 5 minutes or so.
Thanks, Alex. We really appreciate you spending this time with us just before your interview. And it's also really nice having someone who is you clearly honed this and worked on this so much. It's great getting you in at this particular time where this work's really well developed. Let's open it up for questions. John, I can see you've unmuted. I don't know if that's a new unmute.
Yeah, no, it is. Yeah, unsurprisingly. Yeah, no, I absolutely agree with Matt there, Alex. Like, it's really nice piece of work and really well put together and very well delivered. And there's a lot to like about here as well. But yeah, I guess probably the main thing I'm wondering is kind of, and maybe this is where there's a nice sort of overlap between more of the stuff that we do and you do. But so obviously hypothetical bias is an issue for all of our kind of stated preference kind of studies. And one of its, certainly in the discrete choice experiment literature, one of its sort of main consequences is thought to be kind of overestimation of willingness to pay, related to the fact they're hypothetical choices. That is, I'm way more likely to tell you that I would spend money in a survey than I perhaps would in real life as well. So one of the ways that we kind of typically get around that, particularly if we've got revealed preference type data, is jointly modeling them. And I'm wondering here whether it seems like that will be possible with what you've got. Although I think you seem to have used your RP data as a sort of validation exercise, which is fine. People in the literature that I'm aware of also do that as well. But I'm wondering if you could jointly estimate those, adjust your scale in your SP, and then rerun your willingness to pay estimates and just see if that sort of makes any difference as well, bearing in mind the clear and valid points that you pointed out with RP, i.e. we have fewer observations, we might have some sort of omitted variable bias, there may be some sort of endogeneity going on, none of which we can really observe. But I'm interested in your thoughts.
Thanks for the suggestion. I think that I could definitely do that. I mean, as you also mentioned, John, is that I think that it wouldn't make a difference given what we saw on the actual booking that, but I think that that's a nice angle to do. I mean, partly I use the approach that I use in a sense to, kind of like I'm thinking about one of the, this is the evangelical sort of angle to this, is that I'm trying to convince the experimental economists and a bunch of, more hardcore experimentalists to say, look, you could do this. And this was just like, I guess, like the more like simple way. I was like, look, we estimated again, and it looked the same. Again, but I think that the more sophisticated approach potentially is to do it like how you mentioned it, the jointly. So then in that case, right, I could get all the information that I want out of the choice set, and yeah. And I think that the other thing also is that, if my estimates are less precise, I'll be much more inclined to also do this, because you want to extract all the information in one go. Here, I was fortunate that it's not necessary the thing, but I think that you're right that if one do an exercise like this with incentivized, validated, or just validated and not incentivized necessarily, I think that your approach is probably like a preferred way to do this. I mean, I think it's so quote unquote the right way to do it. I think that's true. Yeah.
I've just got a bit of a follow-up there, because I think you said that the results are indistinguishable between the revealed, call it the revealed preference and the stated preference. So what does indistinguishable mean?
Yes,
Like, how does that affect whether we think endogeneity is present in that revealed?
Yeah, no, absolutely. So right, they actually, so the two things actually embedded in this. One is I'm saying that the preferences estimate from the good data and the potentially not so good data looks similar. That's one thing. The second thing you didn't quite say, but because you're nice, I'm going to say it because I'm mean to myself. Is that the estimates from the actual choices are very noisy, because that's the point, right? You have like only one person making one choice, so you have this crazily huge standard error. So statistical indistinguishable doesn't mean a lot, because if you have like a crazily big error bar, it's like everything is within the error bar. And so let me try to talk about these 2 points. The first point about the differences is that, well, one thing, let me actually ask the second point first, which is why I try to make the comment to say both the magnitudes, and the statistical thing, it's both. So that gives me more confidence, because I could have just used the actual booking data, and I could actually just tell the same story that I told, right? Lots of discrimination in baseline, and it shrank by a lot. And obviously, the difference is that when I use the actual data, when they shrink, you cannot see the significant residual, even though the point estimate is negative and so forth, right? So it's hard to tell that story. So the magnitude point is a good point for me to at least feel a little bit more comfort about my second critique about this. The first critique about, good data, not so good data giving the same estimates. I actually think that could be a problem if we actually see that. So for example, like if in the real world, Black doctors are truly like very different in terms of average quality, meaning that every time you see a Black doctor, they are like always, they're like on average 3 stars lower than the white doctors, right? Or if the Black doctors are always correlated with lower prices or higher prices for that matter, right? Then that could really bias the results in this case. But I think the funny thing is that they actually not, right? If you look at the actual data, the Black doctors have a small average quality difference. And, like in terms of the average prices charged by doctors of different races, they're similar, right? The distribution of prices are, you do like Kolmogorov-Smirnov tests across the 3 different races. There's no difference between the distribution of price and travel distance and so forth on average. So, maybe that's why. The thing is, how we have the credibility revolution and these hardcore people are going to be like, well, they look the same, but you can't say that, which is why when I report my main results, I try to report, look, okay, let me give you the cleanest version because I know where the variation came from for the 14 hypothetical doctors. They're the same with the actual doctors. You might say that, oh, does it tell you something bad about the hypothetical doctor? Good data? I think what it does is that it tells us that, well, even if we have used the observational data, it wouldn't be too bad. And I think that's sort of what I take away with.
Yeah, fair enough. Right, Alex, I heard your alarm go off. You need to go and have a breath and a drink of water before your interview. So on behalf of, all of us who are going to watch the recording in the future, I'd say thanks very much. Thanks, John, for your questions. Thanks, Kate, for your organisation. And we'll close there. So well done, Alex, and good luck.
Thanks for the opportunity. And hopefully the United States is going to win today.
Thank you so much, Alex. Good luck.
Thanks, guys. Bye-bye.
Bye, all. Take care.